Okay, right. I've hit the record button and I've got the. Okay, so ladies and gentlemen, yesterday we weren't quite able to finish the lecture, primarily because I was going through it very slowly, apparently quite slow, much slower than the. Am I muted? No, I'm not muted. You should be able to hear me. Can everybody else? Can anybody else hear me? Okay, cool. Thank you. Right, so majority of people can hear me. So if you can't hear me, I would suggest that you disconnect and rejoin the session. Okay, so ladies and gentlemen, as I was saying, yesterday I didn't get to finish my lecture. I was going slower than Mr. Labia, clearly. And then we had the alarm, which, by the way, was a fire drill, not a faulty alarm. And so I was right to ask you to evacuate. Right? Although you all evacuated very badly. Fail, people. I said orderly, and then all of you just mowed out the same. So basically, if a real fire had taken place yesterday, we'd all be dead. All of us. Okay? And so we just have to be aware that sometimes if this happens, please, we do have fire drills. Apparently, Mr. Labia's venue, he just went and he lectured through the rest of the fire drill, which was even worse. So please note, in future, if there is a fire drill, we have to comply because you don't know if it was a real thing or not. And honestly, they should have told us that there was a fire drill. But then I know that Mr. Labia would have said, fire drill, and then he would continue lecturing, which is what he did. Okay, so ladies and gentlemen, just be aware that maybe in future, if you hear an alarm during a lecture, it might be a fire drill, it might be the real thing. Please don't just sit there and go, leave me alone, let me work. It does happen, I know. But, okay, so what I want to do is actually talk about that alternative to the while loops, which we started on. And hopefully some of you were already seeing that, hey, you know, this alternative to the while loop is actually a very good thing. I don't know if any of you saw it as, hey, I would prefer to go with the for loop over the while loop, even though it's new work. Anybody online who feels that? Anybody physically who feels that? Just a few of you. Okay. So you're not convinced yet that the for next loop is actually the better way to go. But let's see why it is the case when it comes to arrays. Okay. So specifically, we are saying that when it comes to working with arrays, you actually want to use a for next loop over a while loop. So let's check that out. Okay, so we all talked about the format of a for next loop. Specifically, with a for next loop, you specify a start value as well as an end value. Now, you do specify a start value and an end value in a while loop anyway, but it's just the way you describe it here in your code that, for me, personally, it makes more sense for me to go with a for next loop because you write less lines of code for starts, okay? But some of you are like, no, I wouldn't want to do this because, number one, it's new, so you're not familiar with it. And number two, we have this big problem of, this is a simple problem. It is 1, 2, 3, 4, which is fine, all right? That's a simple problem. And you can see that with writing your code in with a while loop, this is what you're used to. You know how to do that. You first set up before your while loop, you indicate the starting value is 1. And then your while loop says, well, keep repeating this until we get to a point where it's no longer less than equal to 4. Because if it's no longer less than equal to 4, it means we've hit 5. And do we want to add 5 to our sum? No, we don't. So this makes sense. However, with regards to the for next loop, what's happening there is we still initialize sum to 0 because that's got nothing to do with the loop itself. We need to start the sum at 0 before we start adding values, right? And then it says for counter is equal to 1 to 4. So all that's what it means is a for next loop says, listen, take a variable. This variable's name is counter. It is an integer variable. And it must take on the value 1. And it must count from 1 all the way to your ending value, in this example, 4. So in other words, it's like me telling you, hey, can you please count from 1 to 10? Right? And so you will go do that job. Tell me, go through it with me. Count 1 to 10. Go. You're terrible at this. Person who is late, count 1 to 10 for. Everyone, look at him. Look at him. Wave to him so he gets our attention. Count 1 to 10. And why'd you stop there? Why'd you stop there? That's basically it. A for next loop says start here, end here, and do that. Do exactly that. Don't go up to 11, 12, 13, because you know you must stop at 10. But the other thing you also notice that he counted like a normal person. He went 1 and then he went 2. Then he went 3. Then he went 4. How common. Right? Come on. Surely you can do a little more advanced. I mean, some people count, 1, 3, 5, 7, 9. But that's not what a for loop can do. So you're like, for loops suck. But it's not true. You see, what happens is, if we had a problem where we said, okay, with a while loop, we can control how those increments go or decrements go. So it can decrease each time or it can increase each time. We can do that with a while loop because in a while loop, we write the code that says change that value as we go along. But with a for next loop, we don't have control over that, or do we? So if you take a look at this question, which is the exact same problem, 4, 3, 2, 1, which I said in class yesterday, that in a semester test, if we ask this, you can't go, no, this is reverse, so I will do the exact opposite. I will calculate, I'll write out code that works out 1 plus 2 plus 3 plus 4, because I know how to do that. I don't know how to do it in reverse. I'll do it 1 plus 2 plus 3 plus 4, and you're going to give me the marks. And the answer is no, we will give you 0, because it's not about you being able to calculate the sum at the end of the day. That's not what we care about. It's about you knowing how to write the code to work out the sequence we want you to work out. Okay. All right. So what happens is we want you to work out the while loop in such a way that it is 4, then 3, then 2, then 1. In the semester test, if we ask this, that is exactly how you must do it in the order we give it to you. Now, with a while loop, that's easy because with your code, you will say, well, the counter changes by -1 each time. Easy peasy. But then I've got a big question mark here and say, oh, but how do we do it for a for next loop? Right? And some of you will have peeks at the code. I don't know. Did anyone peek at the lectures to go, oh, I want to know? Oh, but some people online, maybe they have looked at it, or they are repeating this module, or they have looked online. But anyway, here is what we can do with our for next loop. So over here, you will notice that I've added 2 additional bits to the for next loop structure. Okay, so please note that this is very optional. You only do these last 2. So in other words, you in your for next loop, at the end, after the end value, so you say you end at 4, you would then add in step. Step is what you want the change to be, and you provide the increment or decrement value of that step. So in other words, if you don't put it in, the for loop says, okay, I assume you are adding by 1 each time. This is how people normally count, right? We all normally count 1, then 2, then 3, then 4. But instead, what we're doing now is we're going to say, fine, I don't want you to do it the normal way. We want you to change the incrementation or the decrementation by this value instead. Okay, so if you look at that, then we will have our control over what the change should be. Okay, so if you take that into consideration, then you'll see that to achieve the same thing as on the left with your while loop, all you really do is you go step -1 for our problem for the for next loop. Does this make sense? What are you changing the value by each time? -1. So you start, and you see here, we go for counter is equal, what is the start value? 4. What is the end value? 1. What must it change by each time? -1. So you go step -1 and it loops. Okay, so someone might go, what will happen if I go for counter is equal to 1 to 4, step -1? What do you think is going to happen? So think of it this way, you got counter, starts at 4, all right? And equals to 1. This is the, but now we said no, we go counter is equal to 1 to 4, step -1, all right? And then we say do, and then we decrease by 1 each time. So we say start at 1, you must go from 1 to 4, but each time decrease by 1 each, and when does it decrease by 1? When we execute the next. So next goes, give me the next value of what counter should be, all right? That change must be -1 each time. What do you think will happen in this code? So we've got people saying there will be an infinite loop. Who thinks it will be an infinite loop? Some hands, just like 2. Others are like, too early for this. Okay, so okay, the concept, the idea that maybe it might be a negative loop I can understand where you're coming from, and I can see, yeah, it probably makes sense. Right, so here is what actually happens. So you've got for counter equal to 1 to 4. Okay, so what it does is the first time you run the code, it says, counter must take on the value 1, because that's the starting value. It's going to then execute the code of sum is equal to sum plus counter. What is the value of sum? Sum is 0. 0 plus counter. What is the value of counter? 1, right? So it adds 1 to your sum. So what is the value of sum at this moment? 1. You agree? Then it goes to the next line. It says next counter. What will next counter be? So what is the value of counter at this point? 1, right? And then it says, give me the next value of counter. You know that the next value of counter must change by -1. So right now it is 1. 1 minus 1 gives you 0. So then counter is now the value 0. You agree? And then it will jump back to the for next loop at the top. And it will say, I will repeat this. If my loop, if counter is within the range 1 to 4, is my value within the range 1 to 4? No, because 0 is outside the range, so it stops that loop. Does that make sense? So it doesn't actually have an infinite loop problem. Unlike the while loop, you are less likely to have an infinite loop issue with a for next loop. All right. And also, let's be honest, how many of us would rather write that many lines of code for the while loop when you can do it in less for the for next loop? Have I convinced you yet? Who's rather going to do the for next loop if possible? Well, once you've mastered it, of course. Okay, still not many people. Some people are like, Oh, I don't like it. Okay, so the online people are like, they prefer. Okay, obviously there's gonna. Is there anyone who still wants to do a for next a while loop? I don't know, but it's up to you. Okay, actually, technically, it's not up to you. What's going to happen? Yeah, there's like this choice. It's like dangle. There's a choice. No, there's not. What's going to happen in the semester test, the first semester test? Do you have a choice? No, you don't have a choice. We will ask the question very specifically and we go, answer this with the for next loop. Or we go, answer this with the while loop. So what we'll normally do, if you look at the semester test, is we'll give you the while loop version of something and we say, oh, look, here's the while next loop version. Give us the for next loop version of it. Or we give you the for next loop version and say, give us the while loop version of it. So what does this mean? It means that you can't go, you know what, you've taught me 2 ways to do repetition. I only need one of them. I'm going to study the one. You need to know them both and you need to be very familiar with the both. Right? Okay. Here's the thing. When would you use a for next loop? When would you use a while loop? Because I've told you in the past that we're going to teach you more tools as we go along. And you've realized by now already that once we taught you the while loop, and I said, you're able to do everything you want. You're like, yeah, I might be able to solve all the problems, but it's not solved in the best way. And the same thing happens with the for next loop and the while loop. Sometimes things are better solved with the for next loop. Sometimes it's better solved with the while loop. Can you solve any problem with only a for next loop? Sure, absolutely. You can. But as I said, in some situations, it makes more sense to work with a while loop. And in some cases, it just makes sense to use a for next loop instead. So the rule is this. When would I use a for next loop? You would typically use a for next loop when you know the start and the end. So if you know exactly how many times you need to repeat this, you would use a for next loop. Now your question is, well, what do you mean by if you know how often I must repeat something? Does that mean that for a problem like the one we've been working now where you don't know how many times the user is going to add numbers, we should rather use a while loop instead? No, you can use a for next loop and I would prefer to use a for next loop for this problem. Why? Because it's not that you don't know how many times it must be repeated. You do know. It's that you don't know at this point. When you're busy writing the code, you do not know how many times you need to repeat it. But when will you know? The minute your user says this many numbers. Because the minute they say, I intend to add 100 numbers, it immediately means, okay, you must repeat, start at 1, end at 100. Does this make sense? Okay, a while loop is used more on a case of if you don't know how many times it must be repeated and there's no way for you to really determine because it can stop at any time. So an example of that is the following. You would like to keep asking until the condition changes in your favor. Example, you want to go to a party this weekend. You need some money for that. So you ask your parents or your guardian, may I please have some money? Who for you is like, you know that if you ask your parents exactly twice, you will get it. Anybody? No. Sometimes you ask the first time, it's okay, right? But sometimes you're like, please, 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 please. And you keep going until eventually, yeah, they're going to say yes. But you don't know how many times, do you? Online people, is there anyone online that knows exactly how many times you must ask your parents or guardian for money before you get it? Okay, Kale Maraba's like, they never get it. Okay, so then, but then would you use a for next loop? Because a for next loop would be, I'll start once and I'll do it 10 times. You might not get it. right? So you use a while loop instead. And yeah, you'll be infinite looping. Yeah, so some LPTF was like, I don't even ask. All right. But the point is, this would be an example where you use a while loop. Does this make sense? Because a for next loop is very specific. It's start here, and we know repeat exactly X times. Now with a dynamic array, the reason why we want to use a for next loop is because you know the size of the array. Because remember, you find out from your user how big is this array going to be, you set the size of the array, and now you use a for next loop because you say start at element 1, right? And keep repeating, as in ask the user what's the value, and put it into the array 1, 2, 3, 4, 5, and so on until the end of the array. And that's why a for next loop is really preferred for our arrays. Okay, now one of the questions I actually want to ask is, what is the value of counter after the for loop is exited? Now this is really important that you put this in, that you're aware of this, because this is something that causes a very common problem for people writing code in their semester tests. Whether it's the first semester test or the second semester test, this can make or break your program. In fact, if you get this wrong, it can mean you passing or failing the project for the semester test, or even would you get a distinction or do you not get a distinction? Something as common as this can trip you up. So there are people online who are saying, well, they think the counter value will be 1. Some will say 0. What do you think, online physical people? So the online people are contributing. They're saying, so it's between 1 and 0. What do you think the value of counter will be in this question? Now, we went through this example just now. We went through the whole thing about the range. So if you leave this for loop, so obviously you exit the for loop, and then whatever code's after next counter you want to execute, let's say you put a message box up and you say, show me the value of counter. What will the value of counter be? Now, the answer is, some people are like, it might be 1, it might be 0. There's a person who says it's 3. Physical people, yes, go tell me. Okay, so you've got 0. Who thinks it's 0? Okay, few your hands. Who thinks it's 1? Who thinks it's 3? No, nobody thinks it's 3. But there are a few people, but more people who think it's 0. Why is it 0? Because remember we said, if we go through this example here, we start with counter is equal to 4, right? And it will stop at 1, okay? And you must decrease by -1 each time. So we start with 4, so the value is 4. We do the sum, next counter. So when you execute the word next count, the line next counter will decrease the current value of counter by 1. So it was 4, it now becomes 3, right? Then it goes to the top. Now the value is 3. Counter is 3. Is counter, the value 3, within the range 4 to 1? Yes, it is. So we'll repeat the code. Get to next counter. The current value of counter is 3. 3 decreases by 1. So now the value is 2. It goes to the top again and it says, okay, my value of counter is currently 2. Is it within the range 4 to 1? Yes, it is. Execute. Counter is now the value 1. Go back to the top. Is 1 within the range 4 to 1? Yes, it is. So execute the code. Next counter is 0. Goes back to the top. Counter is the value 0. 0 within the range 4 to 1? No. So it does not execute the code sum is equal to sum plus 1. And it leaves that for next loop to go down to whatever's after the next counter. Does that make sense? Therefore, the final value of counter is 0. All right, 0. It will not be 1, because if it was 1, it would repeat the code so that your counter gets changed. And this is one of the common issues that get made, that come up often, where people think they can rely on the value of counter being 1 in this example with the code going forward. All right, if it were 1, it would not have left the loop, because 1 is still within the range 4 to 1. Okay, So the number adder now with 4 next loop, so that's the same code. And there you will notice that what I've changed is over here, I use the 4 next loop to specify my labels, all right? And then I do, now we got rid of note that we got rid of initializing counter, and we no longer need to add 1 to get to the correct row for the sum now. Okay, because the 4 next loop is handling the counter value for us. Okay, and then in terms of working with the input, you'll see the same thing is happening. Numbers counter is equal to Cin. Again, I do not initialize counter to 1. It's been done for me. All right, and then over here, you'll notice that the rows, grid my numbers.row is equal to counter only. I don't plus 1 here. If you're not sure what I'm talking about, you will notice that in my previous code, I actually had to add 1 each time to the counter. But the reason why we don't have to add plus 1 to the counter here for that row for sum or for that row for displaying the sum is, remember, we just had this discussion that counter would be the next value. And since this one's not decreasing, it's increasing, it would be the next row anyway. All right. Okay. So let's continue. Remember, I don't have audio on the laptop, so you raising your hand is not going to help. You're going to have to tap out your text questions. Okay. So there's more wishes on our wish list, and what that is well, what we hate repeating code, obviously. And then there's another slide just to repeat that we hate code. So you're wondering, is this a mistake? No, it's not a mistake. So we hate code, repeating code. We love code, we just hate repeating code. Okay, and that is the repetition code I'm talking about. You see the repetition we're talking about. Dot row, dot col, dot text, dot row, dot col, dot text. That sucks. So what are we going to do? We are going to next. How do we not repeat the constant row, column, text specification? Right, and that's where the other slide now comes in. Let's do that. Slideshow clearly. Yay, okay. So now we are at modular programming, and we're not going to be able to finish this lecture today, obviously, but the idea is to get you as far as possible. Okay, so a quick recap, and I'm not going to really go because we just talked about it now. So we are currently on a journey to go from this to this, yes? And we've been doing this with our code, and so the idea is that we did split it up so it becomes more modular, but there is still this problem. Remember, we just talked about this, so hopefully you remember. And repeating code is really bad because it's bad for maintaining code. You know, some of you go, oh, no, it's cool. We repeat the code and we need to make a change. So all we'll do is use find replace. And ta-da, problem solved. Does that really solve the problem all the time? No. In fact, this is one of the reasons why code goes horrendously wrong. Because you think, I'll just do a find replace and just make changes to everything where there's a reference to the repeated code. It doesn't work that way. All right, so can we go more modular? Obviously, otherwise we wouldn't ask this question. So what do we really do here? Well, what did we do when we made this more modular? Effectively, what is a program? A program is, you know, there is our container, our big container. This is our class. We have the private class, name of our class, end of our class. You know, there's the start and the end there. Okay, there's the start, there's the end. You're all familiar with that. And what we do is we declare some variables there, right? And then we wrote our code separately. We split it up and we wrote it in its own little paragraph, so to speak. And we did the same here. We basically have paragraph, paragraph, paragraph. Each one is in its own little sub-program. And so let's look at this again. What were the commonalities here? In other words, what are we repeating over and over again? Because that's what we would like to do. We would like to try and take those commonalities and put it into a special little program of its own so that we can just call that over and over again every time we need to place something in the text in our grid. Okay, and so we do set a row, we set a column, and we set the text in that row and column, and we do it again and again and again and again. So in other words, what we would like to do is we would like to set a row, set a column, and then specify what text it goes. Now, so let's create a mini program that does that. So how do we create our own little mini program? Because up to now, what do? We double click on a button, or we double click on a form, and it generates the container for us. Can we do it ourselves? Oh, absolutely. You just find an open space, not inside one of those containers, outside, but within the class. And you start by typing private sub and then the name of your subroutine, whatever name you want. And then you can put your code in there. And then you have an end sub, which Visual Studio will automatically do for you the minute you go private sub, whatever. Right. And yes, that's really it. You have created your own subroutine. Now you're like, no, I haven't really created my own container. Yes, it's true. You created your own container. You need to write code in there. And you need to write code that actually does something. Now, once you've written a code, you actually want it to be executed. So when do you execute it? Well, whenever you want to use that program to do something again and again and again, you would basically call it. When you call it, so here is an example. So this was a button, perhaps, that you double-clicked on. And when the user clicks on that button, you want them to execute this little program you've written. Then you call it by simply using the name of the subroutine that you called it up there. All right, so here is an example. So maybe something like this. So remember, at this point in time, we don't know which row, we don't know which column, we don't know what text, but what we'll do is when the form loads, we'll go place text IG, okay, because that's the name of our subroutine. You see, we created the subroutine there, place text IG. So what happens is when the form loads, it will say place text IG, it will jump to here and it will execute the code here. Now, what does this do? The form loads and it will ask the user, hey, which row? Hey, which column? What text do you want to do that? Is that really what we want? Can you imagine? Your program starts and it asks the user, hey, which row? Which column? And what heading do you want to put in the heading? Is that the user's job? No, it's not the user's job. The user shouldn't do that. You should do it. Okay, so that's not quite right. Right? It's not quite right, but you see where we're getting. We're inching closer towards this whole thing of every time we want to place something in the grid, we're going to call the subroutine and it's going to do its job of placing the text in there. But we don't want them to ask the user what values. Your program must talk to your program. Your code must talk to the subroutine and say, listen, we want you to place these values in there instead. Okay. And so the answer is obviously no. And why not? Well, what could go wrong? We've just described it. You don't want to use it to tell us this information. You actually want the following. Okay. And we're going to work on this in the next lecture. So I'm gonna, however, it's the week, the weekend is coming. It's a long weekend. No, you won't get the Monday lecture. You're gonna sit today, tomorrow, Saturday, Sunday, Monday, Tuesday going, but what's the answer? Don't worry. We've given you the answer here. Here is the answer. We will explain this code in great detail next week, Wednesday. All right. So for those of you who are like, this will bug me, here is the code, here is the answer, and we promise this is the correct code. All right. We will explain how it works. It is very similar to whenever you call the function cstring, cin, cdbl, where you say, hey, convert to string, go do your job. But what does convert to string need? it needs some value to convert to string. And the same thing is happening here. You go, hey, place text in the grid. You need to tell it, go here, so this row, this column, and put this text there, so that this subroutine can then do its job because you've told it what information it needs to go. And you can see that I do it twice because one to put it in this location and the other one to put it in the next location. But the idea is by doing it this way, you are cutting down, you having to go row, column, text, row, column, text. All you do is you call it and say, I'll tell you what to put there, you do the placing yourself. All right, okay, yeah, long weekend, clearly. And you don't have to think about, oh, what is the answer? Okay, so enjoy your long weekend, ladies and gentlemen. And